Question is, you're running rail perpendicular to the rib on a commercial solar system. How many more feet do you use than a system that uses a parallel configuration? Let's find out. Vela here from Greenwood Solutions. We're talking commercial roofs, we're talking commercial solar, we're talking rail, perpendicular to the rib. How many feet do we use? Let's find out. Like in past presentations, we've looked at solar panel rail framing from the perspective of parallel to the rib and perpendicular. And we examined how to calculate the amount of rail and minimize wastage. And in this presentation, we're going to go a step further, and we're going to look at putting together a simple spreadsheet that calculates the number of feet required for a rail run that is perpendicular to the rail. Rail feet placing is determined by an engineering report based on wind loads, roof height and other criteria, and this determines max spacing. But when running rail perpendicular to the rib, the final spacing is determined by the space between the ribs, centre to centre. Like all scenarios involving commercial solar calculations, got to make some assumptions, and these include the following. The spacing between the ribs, centre to centre, is 233.3 millimetres. Now, due to thermal expansion, the max unbroken length of rail is 30 metres. Now, when I say unbroken, I'm not including rail joiners. I'm saying an unbroken length of multiple rails joined together. So 30 metres. Calculations concerning actual rail lengths are already known, and we've covered this in previous presentations. The max spacing for the feet is determined by the engineer, and in this case they've said 1,000 mil for all the examples we're going to talk about. Now in this table we're looking at rail length, the number of panels, the description and the dimension. So we've got 11 panels with a width of 1,000. We've got 10 mid clamps, 25 mil each. We've got 2 end clamps, obviously. We've got a rail end buffer, 50 mil both sides, and that comes up to, how good is your maths? A total of 11,410 millimetres. Now, as well as the max spacing, the engineer has said the cantilever can't exceed 300 mil either side. So we've got to effectively subtract 600 mil in total from the rail length of 11,410. So we've got the rail length of 11,410 mil, remember? Cantilever is 300 mil both ends. Total length is 10,810 millimetres. As well as the max spacing, the engineer has said, as mentioned before, that this cantilever can't exceed 300 mil either end. So as we have max feet spacing between the feet of 1,000 mil, we just divide 10,810 by 1,000 and we get a figure of 10.81. So the next step obviously is we have to round up. So we round up to 11 and then we add 1, of course, because we've been calculating the spaces. And to calculate the feet, you have to always add 1. So that means a total of 12 feet times 2, so top and bottom rail. So we're looking at 24 feet in entirety. But hang on, the spacing between the ribs are at 233.3 millimetres. So the max spacing is determined by that rib spacing, and that is 933.2 millimetres, which equates to 4 times 233.3. So you can see what's happening. The engineer has said 1,000 mil max, but we haven't got increments on the ribs of 1 mil, so we can't get that exactly. Our increments are 233.3 millimetres, so we basically have to find a multiple of that increment that is less than 1,000, and that's incredibly important. So the question is, does this alter anything at all with this 11 panel configuration? So we get that figure of 10,810 mil and we divide by 933.2 and we get a figure of 11.58. So we have to round up to 12 and then we add 1. So now we've got a total of 13 feet times 2, top and bottom rail 26 feet. So even with a really short rail run, we're talking 2 by extra feet. So imagine if there were 20 rows with the same configuration. Using the 1,000 millimeter max figure, we would be 40 feet out. Feet aren't that expensive, but waiting around for stock to be delivered that was not originally accounted for means potentially guys on site not having anything planned to do, and this trickles down. And you can imagine that what this implies as well. So this is the kind of feet we're talking about here, and you can see how it actually works. So effectively it clamps on top of the rib. Now if the rib was going from me towards the camera and your design was running the rail parallel to the rib, these would go like this. And that 1,000 millimeter increment, max feet spacing, would not be an issue, easy calculation. But because we're running it perpendicular, we're talking about running it to, there's the next rib, there's another rib, there's another rib. So those distances between center to center on the ribs will determine our maximum spacing. In this case, it ended up being, our example, 933.2 millimeters. We've been given a max cantilever 300 mil each side, but what happens when we use the correct rig spacing? So we look at our 11 panel example. We use a 933.2 millimeter increment. There's going to be 12 spaces. The total is 12 times 933.2. That's 11,198.4 millimeters. Look, the reality is 0.4 millimeters, and you're really not going to measure that out. But hey, that's the calculation. So remember, our total rail length is 11,410. So the cantilever on each side is 11,410 minus 11,194.4 equals 211.6. Numbers. And divide this by 2 to get the cantilever on both ends. And this means the cantilever is now 105.8 millimeters. With this example, we know that feet are being placed every 933.2 millimeters, and this means feet are placed every 4 ribs. So this is easy from an install preparation point of view. But is this all? It sounds a bit too easy. So we've got 29 panels, and the total length, including mid-clamp spaces, end clamp spaces, and buffers, is 29,860 millimeters. And we just divide 29,860 millimeters minus the 600, so that's the max cantilever. And we divide that by 1,000 because that's the original, and we get 29.26. We have to round up to 30 and then add 1. That's a total of 31 feet times 2, top and bottom. You got 62 feet using the 1,000 millimeter increment. But remember, we got these ribs. So by using the corrected figure of 933.2, we end up with 66 feet, and you can do the calculation yourself. Now, again, if we had a 20-row system, this means an additional 80 feet. Now, as I said, feet aren't particularly expensive, but if you don't have them on site, you have to organise. They have to be freighted to site. What are the guys doing? Is there a plan B? Is there a plan C and plan D? So that's all part of that project management brief that a good project manager will understand. But hey, you don't want to be in that situation in the first place. So make sure you do your calculations properly. Now, with our 29 panel example, this starts to get a little complicated. With this particular table, just spend the time looking at the calculations and the cells that I've referenced. And if you need any help, just give us a yell. Now, as we were restricted to the distances between the ribs, achieving an equal cantilever both sides rarely occurs, as 1 extra foot is required to maintain the max engineered feet spacing. So in this example, our 29 panel scenario results in 33 feet for the top rail, which is a total length of 29,860 mil. Our feet spacing is again at 933.2 mil. So let's have a look at the sums. We have 33 feet, but this means 32 spaces. So if we take 32 spaces and we multiply that by 933.2, we get 29,862.4 millimetres. This is 2.4 mil greater than the entire length. Okay, let's try 31 spaces. So we do that. 31 spaces times 933.2 equals 28,928.2 mil, which is 913.8 mil, so many numbers, for the cantilever. And we divide this by 2 and the result is 465.9 millimetres each end. And that's too much, because what's the maximum cantilever that the engineer has stipulated? 300 mil both sides. So we've got to do something about that. Engineer has stipulated a max of 300 mil. And with the 31 space, 32 foot calculation, we've exceeded this, and that's why we need the extra foot. So we can see that the last foot on the right hand side is not on the white line, which signifies the 933.2 increment. Our total rail length is 29,860 mil. Distance between the ribs is 233.3 mil. Max distance between the feet is 933.2 mil. 31 times 933.2 gives you a figure of 28,929.2 mil. The difference between 29,860 minus that 28,929.2 is 930.8 mil. So we have to add another foot, and we have to add that 3 by rib length spacings away. So foot number 32, we add 699.9 mil. So now the distance between the first and last foot is 29,629.1. Now, the difference between the full rail length and feet spacing is 230.9 millimetres. Conclusion. So obviously you have to assess the site and determine if the feet are going perpendicular or parallel to the rib. If perpendicular, you have to look at the max feet spacing and how they relate to the rib spacing. Make sure your feet spacing do not exceed the max engineering stipulation. And you've got to prepare site drawings so all involved understand the design and what they need to do, and I can't stress that enough. Thanks for watching our presentation on rail perpendicular to the rib, specifically feet. I know, not the most exciting of subjects, but hopefully we all learned something. I certainly did. If you like what you see, please hit that subscription button. And if you have any questions, any inquiries, any answers, feel free to drop us a line. See you next time.